numbers, large numbers basically in probability and statistics states that as sample size grows, its mean gets closer to the average of the whole population. This is statistical concept. I'm not going to discuss financial context where law of large number indicates that a large entity which is growing rapidly cannot maintain that growth pace forever. So what do we mean by law of large numbers? I shall demonstrate using Excel as usual. So when number of trials, when your sample size increase, your sample average approaches towards population mean, or you can say its value approaches to population parametric value, and that's also a consistency property. So here I am going to take rand equal to rand, that is generating random numbers between 0 and 1, and I have generated 1000 random numbers here. So you can drag it down and up to 1000. Here I'm saying binomial trial. If our A2 is less than 0.5, then it's tail. If it's greater than 0.5, it's head. So you have head, first trial, head, head, tail, head, head, tail, tail, head, head. No, you have taken number of trials equal to 10. So when you have rolled a coin 10 times, you have 7 heads out of 10. You have 14 heads out of 20. You have 0.63 means okay, 12 and 13, in between 12 and 13 heads when you rolled it 30 times. So as you increase this number of trials 10 times, 20 times, 30 times, 40 times, 50 times, your this number of heads value will start approaching towards zero point 0.5, because we have assumed a fair coin. I have rounded it up to 0.7. So basically what we are going to, you can see formula here, average index B2 to B 1001, C2. Also, this is average of 10 values, this is average of 20 values, 30 values, 40 values, 50, 60, 70, 100 times when you toss it, 48 heads, 52 tails. Now I am going to plot it. I am going to plot these values, not this one, up to, I am going to plot these values up to, we have carried out this trial 1000 times. So in increments of 10, which is in column C. So you see in column C up to 1000. That's it. Now if we make a plot, insert line chart N1, and you see, no, this one, I am going to rub the title here. I never give title inside it. And now you see, in the beginning it's very erratic. I make font slightly smaller. Okay, in the beginning it's quite erratic, but in the long run it start approaching 0.5, 0.5. If you do this another time, again, if you do it in another time, so you see again it's erratic in the beginning, but as number of trials increase, it approaches 0.5. Do it again, so again you will see a different pattern, but in the long run it start approaching 0.5. That's what is that law of large numbers. If you roll a coin a large number of times, if you play a casino game, it's not that in the first, second, third, fourth, you may win all, you may lose all. So if you keep on playing a large number of times, then on average you'll be if it's a fair game, you'll be at 50-50. Okay, I hope you can do it. First, I'm going to repeat it a few seconds. I have random numbers here. Then I have put a if condition here. And then number of trials I have listed here. I have used a formula: average B2 B1001 C2 means 10 trials, 20, 30, 40. So as number of trials increased, and then I have plotted it as number of trials increase: 100, 110, 500. Number of probability start approaching towards zero point 0.5. That's all. Thank you for watching. Take care.